Hello everyone, in this lesson, we will study the hole modeling command in the NX 10.0 software. In UG design, hole modeling is a commonly used operation. When creating part models, many features are involved. The assembly of parts often requires threaded holes for fastening, so the hole command is frequently used in our part designs. UG hole modeling operations are flexible and device, allowing the automatic creation of various types of holes. The UG hole command is very powerful. This time, we will explain the operation of three commonly used commands: regular hole, countersunk hole, and threaded hole. Since hole modeling must be based on a solid, we need to first create the required solid model. First, click the Extrude command on the toolbar or go to the drop-down menu, Insert, Design Feature, Extrude, select the curve, click on Sketch, and enter the sketch environment. Draw a simple rectangle contour and draw a circle in the center of the rectangle. Add dimension constraints to the contour, click Finish, and exit the sketch environment. Set the extrusion direction to the Z-axis. Set the extrusion height to 50 mm. The drawn curves can be extruded in two steps. Extrude the rectangle contour first, then extrude the circle. The extrusion height of the circle is 100 mm. Then select Union in the bowling operation to complete the required model. This also reveals the use of the Extrude command. Next, we explain the hole command. Click the hole command in the toolbar or in the drop-down menu. Click Insert Design Feature, Hole. The system will pop up the hole dialog box, such as regular hole, threaded hole, etc. The shapes and size of regular holes includes simple hole, countersunk hole, counterbore hole, and other hole modeling types. Next, we will explain the commonly used hole modeling methods. Next, we begin explaining the hole command. First, bring up the hole command and select the hole type as regular hole. In the positional area, we need to specify the location point. Clicking on the model surface will automatically enter the sketch work environment. We draw the point location in the sketch, and we can draw multiple points at once. When clicking the first point, the system will automatically generate a coordinate system. We can determine the point location based on this coordinate system and add dimension constraints. When all holes are dimensional constrained, we click Finish to exit the sketch work environment. In the shape area, choose Simple Hole, specify the dimensions, and enter the diameter and depth. Please note that the depth here refers to the distance from the hole surface to the bottom of the hole. As we all know, a standard drill bit has a 118-degree tip angle. The depth here is measured not to the tip of the angle, but to the bottom of the angle. So, when determining the depth of the first hole, make sure to confirm the drilling depth. In the Boolean operation, choose Subtract and select the rectangle we just modeled. Click the Confirm button to complete the hole, which is drilled on the polygon. Next, we demonstrate drilling a hole at the circle's center. Distinguish it from drilling on polygon. Bring up the hole command and specify the point by selecting the arc center. Note that selecting the arc center does not enter the sketch work environment, but directly determines the arc center point. This is because the center has only one position, which is fixed, so it doesn't require dimension constraints in the sketch environment. Enter the diameter and depth, click Confirm, and the hole modeling is completed. However, if the selected point is not the center point, the system will automatically bring up the sketch dialog boxes, and the coordinate system will be established at the center. The operation is the same as drilling on a polygon. After completing the sketch constraints, exit the sketchwork environment, return to the modeling environment, and complete the parameter settings. Next, we will explain the modeling of a countersunk hole. Invoke the hole command and select the hole tabs as standard hole. For now, we want to specify a point and will move to the shape position. Use the drop-down area to select a countersunk hole and enter a countersink diameter of 38. Then, enter the countersink depth of 25. Enter the through hole diameter as 25 and the total depth as 50, including the countersink depth. Click to specify a point, select the surface of the rectangle block, and enter the sketch environment. Draw the required point, apply dimension constraints, click Finish, and exit the sketch environment. In the Boolean operation, select Subtract and click Confirm to complete the countersunk hole modeling. Next, we explain the modeling of threaded holes. Bring up the Hole command, select the Hole tab as Threaded Hole, and specify the point by clicking the rectangle surface. The subsequent operations are the same as the previous two-hole Julian method. The system enters the sketchwork environment. After determining the pointer location and dimension constraints, click Finish to exit the sketchwork environment. In the dimension parameter interface, we can set the standard size for the threaded hole. The drop-down size menu will provide options for modeling various threaded sizes. Enter the depth and click Confirm to complete the threaded hole modeling. Note that UJ's threaded hole modeling only shows the thread root diameter, with the outer diameter indicated by a green dashed line. In this lesson, we mainly discuss hole modeling. Please practice more after class to become proficient in the operation. See you in the next lesson.
Hello everyone. This lesson I will introduce to you about the 6th section, Confucius, how to draw a hole. Let's take this 3D picture, drawn last class as a demonstration. We have to find the hole command first. Hold in design feature. Then there are many kinds of holes here. We only introduce 2 kinds. The first is a conventional hole. Then click on the regular hole first. Then you have to choose the point where you want to punch holes here. First of all, you can choose which side to punch holes on. For example, if I want to punch holes in this surface, then click on this surface. Then it enters this interface. Then how to determine the location of this point. We can choose this order here, then restrain it. I don't constraints completely here. I set 6 here. Turn it off. Then just click Finish. So this position is that the distance is this 6 mm position. Need to be punched. Then there are many options. There are simple holes, countersunk holes, and so on. Let's choose simple here first. Then this is the size of the diameter of the hole. This is the value. 4 mm deep is the depth of the hole. And then what this means is, let me show. After drilling the hole, it will have something similar to a conical surface. Its angle is 118, and then one of our holes is made. Then make a dozen other holes. It's also general. Then click on the countersunk head here. This is the diameter of the big circle. This is the depth of the big circle. This is the diameter of the small circle, and the depth of the small circle. Then we have to choose a point first. Here it is. Then restrain it a little here. For example, constrain a 3 or so, then close it. Then finish came out here. Then this side is too big. Then make it smaller. Change it to 3. Then the depth here is also 3. Then the small circle is 2. Then it appears in preview. This major diameter is 3. Then the depth is also 3. This path is 2. This way, 2. This is 118. Similarly, click OK, then make a hole like this. There are also threaded holes. It's also here. Then choose here. The threaded hole is this command. And then here are some parameters. Here are some parameters of the thread. There are all kinds of choices here. Then here are also some parameters. Here is the length of the depth thread line. This side is left and right. This is the depth of the hole. Then here is 118. Similarly, I won't demonstrate it here. It's the same as punching this hole to determine the position. And then notice, the UG thread hole modeling only shows the thread bottom hole. Then the major diameter is indicated by the dashed green line. That's about all the content of this lesson. Thank you all.